Hi there. This week we're going to be talking about the net present value method for considering options. And again, we will always be using these two present value formulas, one of them being the present value for a single amount of money that's payable in the future. So that would be principal is equal to maturity value multiplied by the compound discount factor, and that's 1 plus I to the negative n exponent. The other formula for present value is the one for an annuity, and the annuity consists of regular and equal payments. So it'll be n payments, and so we've got 1 minus 1 plus I to the negative n divided by I. That's called the annuity discount factor for n payments of PMT at an interest rate made as often as the payments are made. Now, primarily I'm going to be using the built-in functions from now on the calculator to compute the present value of annuities, especially since I don't have to worry about the interest rate when I'm using the calculator functions, because I can use the CY to allow for my interest period compounding frequency and the PY for the payment frequency. So let's take a look at the first example. In this example, we have a project that requires an initial investment of $300,000, and it's expected to generate the following revenue. And the revenue is given in a table. So at the end of year one, we will get revenue of $40,000. And after year one, at the end of year two, we will get more revenue of $70,000. So it seems to be increasing in revenue. Year three, at the end of year three, we will get revenue of $100,000. And year four, we will get revenue of $160,000. Now, what you'll notice is that over the 4-year time period, we have total revenue of 40 plus 70, that's 110, plus another 100 is 210, plus another 160 is $370,000. So it's $370,000 payable over 4 years. Now, of course, you know that the true value of that in terms of today's dollar is significantly less, because the total payments have to be discounted if I'm going to get a present value for today's evaluation. So what we'll do is we will determine whether the project is worthwhile if the cost of capital is 10% compounded semi-annually. Now, we know that 10% compounded semi-annually means that the interest rate, I, is equal to 5% per 6 months. Now, I will use the built-in functions on the calculator. In other words, I slash y will equal to 10%, and the CY, the compounding periods per year, will be equal to 2 for our analysis. So there are 2 interest periods per year at 10% per year, or I can just use the fact that the IY value, the I per period, is 5% every 6 months. Now, I haven't drawn a time diagram yet, but I think it's really, really important that we focus on the time diagrams in these analyses. So I'm going to compare the value, the present value of the money in relative to the present value of the money out. So let's take a look at the money out, because that's pretty straightforward. The money that goes out is how much I spend on this investment, and I'm going to be investing $300,000 today. So money out will go here at the bottom of the time diagram, $300,000. And so I'm out of pocket $3,000. So we know that the present value of that $300,000 is simply $300,000. I don't need to do any calculating here for that one. Now let's compare that to the money in, or in other words, the money coming in, which is also called income. Well, we're going to get $40,000 at the end of year one. So that's going to give me $40,000 at the end of year one. And then at the end of year two, I will get income of $70,000. And at the end of year three, I will get income of $100,000. And at the end of year four, I'll get income of $160,000. So now what I need to do is to compare the present value of the income over that time period using the interest rate of 10% compounded semi-annually. So how do I calculate the present value of that income stream? Well, I need to calculate, it's not an annuity, so I need to calculate the present value of each payment individually. So I need to discount the $40,000 to today's date, and you will note that with that $40,000, I need to discount it over 2 semi-annual periods, since the interest rate is compounded twice yearly. And I need to add to that the present value of the $70,000 payable at the end of year 2, but I need to discount that over 4 semi-annual periods. And I add to that again the present value of the $100,000 discounted over 6 semi-annual periods, plus I add to that the $160,000 discounted over 8 semi-annual periods. So how do I write that out in algebraically? Well, I'm going to use that using the discount formula. So the present value of the income will equal to $40,000 multiplied by the compound discount formula, 1 plus 5% per 6 months, and I need to discount it for 2 periods, plus the $70,000 discounted at 1 plus 5% every 6 months for 4 semi-annual periods, plus I add to that $100,000 discounted at 1 plus 5% per 6 months for 6 semi-annual periods, plus the last payment of $160,000 discounted at 1 plus 5% every 6 months for 8 semi-annual periods. Now, you could also, obviously, if you were using the built-in functions on your calculator, you would calculate each one individually using IY is equal to 10 and CY is equal to 2, and changing the value in each case of the future value. So the future value for the first case would be $40,000, and you would compute the present value of that $40,000. Then you would simply change the future value for the second payment to $70,000 and also change the end, the number of interest periods, to 4 for the second one and compute the present value. And then you would keep a running total of that in one of your memory keys of your calculator. You should stop the tape now and do the individual calculations and come up with a total for yourself. And the net present value of your income should work out to an amount that is equal to $276,000, $786 and 49 cents. So now what we're going to do is compare what the true value is of this investment. In other words, the net present value of this investment option is equal to the net present value of the income minus the net present value of the cost or the outflow. And the net present value of the income is $276,786 and 49 cents, but the net present value of your outflow is $300,000. And so what this tells you is that it's a losing proposition if we're using an interest rate of 10% compounded semi-annually, because the income is significantly lower than the outflow. In fact, we are, how much? The difference is 23,000, so it's minus 23,200. I'm going to round that off to the nearest dollar, so 23,000. So the net present value of this investment option is a negative amount. It's a losing proposal. At 10% compounded semi-annually. Your proposal your conclusion might have been different if the initial cost was different. Your conclusion would also have been different if perhaps the income stream provided by the investment was slightly different. Your conclusion might also have been different if you had used a different rate. But always, when you're considering an investment, always consider the present value of your cost, in other words, the present value of the outflow of money, to the present value of the inflow of your money relative to the interest rate that you are using in your analysis.